Welcome aboard, mates. This is your favorite captain on wheel, Captain Jack. In the past two lectures, we have studied about the trace selection and calculations in PCB. So, in this video, we'll be practically implementing the rules studied in the theory. This is the pre-made layout of the Curiosity board. I bet you have met him earlier. It has been made on two layers. Can you guess them, scholars? The deep red one is the top copper and the deep blue one is the bottom copper. But what if the design is a lot complex and the designers have space constraints? That's where the inner layers come into picture. So first of all, we have to decide the number of layers over which the tracks have to be made. Otherwise, when we go into the track mode and try to make tracks, we have only two options, top copper and bottom copper option. So if we want to make uh, the tracks from other layers, we'll go to the technology tab, click on the layer stackup option. Over here we can see the various layers that are present on our board. The core that is made of FR4, around which we have the top and the bottom copper layers, which are coated with top resist and bottom resist. So to add the layers, we'll click on the stackup wizard option over here. Over here we have the number of copper layers. Just click on that and we can see that, as I had said, we can make up to 16 layer boards. So for demonstration, I will use 4 layer boards. Over here, we can also define the material, the core material, the surface thickness, the dielectrics, and so on. So click on OK. After I click on OK, 2 more layers are added around the core. Now, the next thing that we have to do is we have to add the vias, because by default, if you see on the board view, the through via is used, which connects only the top to the bottom copper. So to add vias, we select this create from cores option. Then we can see that this has resulted in the creation of via from inner one to inner two layers. But what if I want a via specifically connecting the top copper layer to the inner two layer? For that, I will click on the add option. I will select the specific via that I want to be connected, so from top copper to inner two, and click on OK. So over here we can see, and we can also see in the option of the board view. So just click on OK. So we can make different types of wires as needed. Now you can see in these options that there were only top and bottom covers, but now we have the inner one and inner two layers as well. So after this is done, we can start making the circuits. So after we have decided the paths, the layers, then we have to uh, select the various design rules. Now we can go to the design rules from the technology tab as well. Otherwise, we have a shortcut option over here, the design rule manager. The design rule manager is responsible to make some default changes in our PCB. So the rule name, as you can see, the design rule first rule name is default, and we have the pad to pad clearance, the trace to trace clearance, and so on. In net classes, we can set the default tracks, the default trace style, the default wire style, and so on. So for power, the power, which means VCC and VDD, that are present on the IC. So for that, the trace style has to be a bit more than the normal trace style. By default, I'm using the T40, the 40 thou thickness trace style, but I'll just show the demonstration. Click on OK, and then all the VCC and VDD pins, if they were of some less thickness like T10 or so on, they would be increased to T40. So after this is done, after the design rules are set, the another thing that we had learned, that were the 45-degree turns, the importance of 45-degree turns to avoid the various noises. But I had also shown in the video that instead of 45-degree turns, it would be best if we could use curved turns, curved traces. So in Proteus, we have this option to make the traces to be curved. So what I will do is I will change this trace by, I just click once over here, and then I will drag it to the pin. But you can see a straight line has been made. But if I want a curved line or an arc, I'll just click on the control button on my keyboard and you can see a arc has been formed. I'll just left click so to show that my trace is complete over here, and then again right click to get out from making the trace. Then I will remove this straight line. Now you can see that I have made a curved trace. Similarly, I can do with this trace too. Drag this over here, click on control and select the form of curve I want. Instead of the inner curve, I can try to make an outer curve like this one. Left click and then right click to get out of the trace mode. In this way, we can uh, avoid the 45-degree turns as well and make a curved turn in our PCB layouts. For making the curved turns, there is also one more thing to be checked over here. In tools, we have to check the follow me routing option so that you can make curved turns without any interruptions from the software. After the turns, there is a special feature that we'll discuss that was not covered in the theory lecture. It is called as the teardrop fillet. There are various reasons to use the teardrop fillet in PCB. It may reduce mechanical and thermal stress where the trace joins the pad, resulting in lace hairline cracks in traces. It helps to enlarge the PCB manufacturer tolerance of the drill to the pad. This makes the production of the board easier and reduces rejected board during production. So I'll just demonstrate to show what is the difference between a normal connection and a teardrop fillet connection. So as you can see over here, we have the normal connections. They are usually in the form of straight lines. They're directly connected to the other pins. So if I want teardrop connections over here, I'll just go to technology, select on configure teardropping. I'll check on the enable teardrops option, include on drill pads, and I will uh, make the maximum annular ring and so on. I will make it as 25 so that we can make out the differences between the normal trace and the teardrop trace. So over here we can see we have a teardrop traces. So as I had said, my trace style, the width of my trace has been is a bit large. So I'll just reduce the style. I will go to the cursor option. After I go to the cursor option, in order to select multiple traces, what I will do is I click on control and left click on the traces simultaneously. After this is done, I will right click on them and change the trace styles to say T10. Now over here, if you see this type of connection, the wide uh, the wide diameter of the circle of the pad is being narrowed down until it meets the trace. This type of connection is called the teardrop connection. Now, there is also another feature I would like to discuss in the PCB layout option. That's the last thing I'll be showing in this video, as I find this important too. That is called, this option is called the serpentine length matching of traces. Length matching requirement exists whenever there is a need for data to arrive at the same time. For a differential signal, length matching ensures that the two edges of the signal are aligned and that the signal is truly differential, that is less susceptible to noise and less likely to radiate noise. So here's how we can do the length matching. We'll do the length matching in the small traces itself. So if you can see, this trace is a bit crooked. So if a signal is passing through this trace, it would take a bit longer time than the trace that is passing through this one. So what I'll do is I will select these two traces. I'll go to the technology option and I will go to the configure length tuning. Just don't make any changes over here and click on OK. Just try it again. That's one way of accessing the serpentine length matching. Another way is selecting the traces and right clicking on them. After I right click, I get the option as length matching. I'll do the match this option, and then we see that the lengths are almost similar, so that when signals are passing through these traces, they'll reach at the same time. This video has shown all the important features in a PCB designing combined as a single guide for the designing, but I'll make sure to make separate videos so that my followers may find the required features easily whenever required. After those features are done, we'll move on to the next part of the theory, that is the wires. Till then, adieu followers.